This is an experiment to interface DHT11 sensor with Nodemcu and Thingspeak IoT cloud platform. And for this experiment, we need a DHT11 sensor and Nodemcu and some jumper cables, jumper wire and micro USB cable and one small mini breadboard. To connect this DHT11 sensor, we need breadboard. If you don't have breadboard, directly you can connect with the help of 3 jumper wires to the Nodemcu. So what is DHT11 sensor? DHT11 is a popular and widely used digital temperature and humidity sensor. It is a basic low-cost sensor, and it provides reliable readings for temperature and humidity. The sensor can be easily interfaced with the microcontroller, and a microcontroller like Arduino board or Nodemcu, and even we can interface this with Raspberry Pi. So which makes it popular choice for various projects and involves environmental monitoring and control. And it has some sensing mechanism. The DHT11 sensor consists of humidity sensitive. This has got humidity sensitive capacitive element, and it has got thermistor, that is temperature sensitive resistor. It consists of 2 elements. The first element is humidity sensitive, that is capacitive element, and the second element is thermistor. So thermistor is nothing but temperature sensitive resistor. These 2 components are used to measure humidity and temperature respectively. And from this DHT11 sensor, we get digital output. So unlike analog sensor that provide continuous voltage value, the DHT11 outputs data in digital format. It uses one wire protocol. What is one wire protocol? It has got only 3 pins. One is VCC, another one is ground, and another one is a signal pin. So it has got only one wire to send the data and to receive the data. So it uses one wire protocol, which means it requires only one data pin to communicate with the microcontroller. So how much temperature it measures? What is the measurement range of this DHT11 sensor? The DHT11 can measure temperature in the range of 0 degrees Celsius to 50 degrees Celsius with an accuracy of plus or minus 2%. And it can measure the relative humidity range in terms of percentage. It gives the humidity that is 20% to 90% with accuracy of 5%. I'll show you the exact reading value. See, these 2 are the measurement range. It can measure the relative humidity in the range of 20 to 90% with accuracy of 5%, and it can measure temperature in the range of 0 to 50 degrees Celsius, that is 32 degree Fahrenheit to 122 degree Fahrenheit with an accuracy of plus or minus 2%. This is the measurement range. So the data to get readings from DHT11 sensor, the microcontroller initiates the communication by pulling the data line low for a short period of a time. So it has got only one data line. So the microcontroller or Arduino or a Nodemcu, what it does, this is the central one is the data line. So initially it pulls the data line low for a short period of time to start the signal. After this, the sensor responds with the data. So that is the beginning of the communication. So the various library and codes are available for interfacing DHT11 sensor with the different microcontrollers, so that it becomes easy to integrate into your projects. So it is very important to note that DHT11 sensor is affordable. So the price of this is around 100 rupees and straightforward to use. It has some limitations. It is affordable, but it has got some limitations. What are those limitations? The DHT11 sensor has a lower accuracy compared to one more sensor, that is expensive sensor, DHT22. So DHT11 sensor has lower accuracy compared to DHT22 sensor. For critical application, you may consider using higher accuracy sensors. In that case, you use DHT22. Otherwise, for normal project or experiments, you can use DHT11. And additionally, the DHT11 is not suitable for extreme conditions or high precision applications due to its limited temperature range and humidity range and accuracy. This is a connection diagram of DHT11 sensor with Nodemcu. Very simple. The VCC pin of Nodemcu is connected to VCC pin of DHT11 sensor, and ground pin of DHT11 sensor is connected to ground pin of Nodemcu, and signal pin of DHT11 sensor is connected to D4 pin. We are using D4 pin because in code I have taken D4 pin, so I am connecting to D4 pin. In actual DHT11 sensor, the first DHT11 sensor has got only 3 pins. In this diagram, I have shown 4, but actual the component has only 3 pins. The first pin is VCC, and the last pin is ground, and the middle pin is signal pin. But this diagram I have taken from a Google, and it has got 4 pins. But while doing connection, it will have only three connections. And you do the connection. Again I'll explain this while doing the experiment. This is a code for Nodemcu ESP8266 microcontroller, and microcontroller interfacing with the DHT11 sensor to read temperature, humidity data, and then sending the data to the Thingspeak platform for storage and visualization. Note down here, we read the temperature and we read the humidity, and after reading both the parameters, we send to the Thingspeak platform for what we are storing, for storage and for visualization. Thingspeak is an IoT platform that allows you to collect the data, and it allows you to store the data, and it allows you to analyze the data from the connected devices. Now I'll explain the program. The first line is, this is your first line, hash include, I'll keep this side. The first line is hash include ESP8266 Wi-Fi.h. This line includes a necessary library to enable Wi-Fi connectivity for the ESP8266 Nodemcu board. So to include a necessary library file which to enable Wi-Fi connectivity, this header file is used. Next, second one is hash include DHT.h. This line includes the library required to interface with the DHT11 sensor. The first one is library to enable Wi-Fi connectivity, and second one is library to interface with DHT11 sensor. And the third line, hash include thingspeak.h. So this line, the third line, this line includes Thingspeak library, which provides functions to interact with Thingspeak platform. So it will include Thingspeak library. That's why it is hash include thingspeak.h. Next one is DHT, fourth line. DHT space DHT-T4, DHT11. This line initializes DHT11 sensor. We are using DHT11 sensor on Nodemcu board, and D4 pin is used for communication with sensor. So it has the type of the sensor we have to declare here, that is DHT11. If you are using DHT22, here you have to write DHT22, and which to which pin we are connecting the signal pin of DHT sensor. Just now I explained it is connected to D4 pin. So you can connect to D1, D2, D3, any pin. Which pin you are using, that pin you have to declare here. So that is initialization. Next is Wi-Fi client. Wi-Fi client space client. This line declares Wi-Fi client object that will be used for communication with Wi-Fi network. So to communicate with Wi-Fi network, so we are declaring Wi-Fi client. Then next line is long my channel number. So this is the channel which we create in a Thingspeak. That channel ID we should copy and paste it here. This variable stores the Thingspeak channel number where the data will be sent. So one more I'll tell. After that I'll go to the Thingspeak channel. The next line is constant character my right API key. Some number I have written here. This variable stores the right API key for your Thingspeak channel. So this key will allows the microcontroller. Using this key only we can means the microcontroller to write data to the channel. Without this key, the microcontroller Nodemcu cannot write data into the channel. Now I'll pause the explanation of the program here. Now I'll show you how to create a channel for our DHT11 sensor in Thingspeak. So what I should do, first I should click on Chrome. And in Chrome, you type Thingspeak. Press enter. So my network is little slow. It is taking some time. So after typing Thingspeak and entering, it will ask us to enter the mail ID and a password. I have already entered and I opened my Thingspeak channel here, account here. So here you go. Here I'll type the email ID. Go next. It will ask us to type the password. So after entering password, my channel got opened, and here I'll go. It is in channel, and click on new channel. So here you write the name of the experiment, DHT11 sensor with Nodemcu. So here you can type the description. To measure humidity and temperature. So how many data I need? I need data, 2 datas I want. One to measure the temperature and another one to measure the humidity. So I'm using two variables in my program, H for humidity and T for temperature. In the field 1, I'll just type H, small h I have declared. And in the second field, I have to type anything into field 2, you have to click here. So then you can type T here. So after that, I have declared only two variables. I'll declare in field 1 H and field 2 T, and I'll save it here. Save the channel. Okay. So after saving the channel, I will copy my channel ID in my program, Control C. So I'll go to my channel ID. So this is my channel number. I'll paste here. Earlier it was something. Now I'll paste my channel ID. Again, I'll go to the Thingspeak channel, and there I'll copy the API key and paste it here. So I'll go to the Thingspeak account. So I'll come here. So the two charts are displayed. In field 1 chart, DHT11 sensor with Nodemcu. The vertical axis you see here, it is H, and in another chart the vertical axis T is there, one for humidity and another one for a temperature. And to get my API key, you just click on API keys. So here I'll get a right API key. You copy it, copy the API key. Copying API key from the Thingspeak channel, you paste it in your program. These two, sorry, it has not been copied. I'll again go and copy there. Where it gone? Yes, I copied my API key in my program. So these two are very, very important. You should copy channel number from Thingspeak account and paste it here, and you should copy the right API key from Thingspeak account channel and paste it here. After doing these two steps, we will enter into the setup function. So in void setup function, this is the setup function which runs only once when the microcontroller starts up. Then after that, we have a serial begin 9600. So this serial 9600 initializes the serial communication at a baud rate of 9600, and it allows you to see the output on the serial monitor. Without this, we cannot see the output in the serial monitor. So if you want to see the result in serial monitor, and you should declare serial.begin bracket 9600. After that, we have a command Wi-Fi begin, and name of the SSID and password I have given, service set identifier. This initiates the connection to Wi-Fi network with provided SSID. My SSID is Shanta CM, and my password, something I have written here. This is my password. So it initiates the connection to the Wi-Fi network. Then it checks whether the connection we got it or not using while loop. While Wi-Fi status not equal to WL connected. So this loop checks the Wi-Fi connection status. While the connection is not established, if the connection is not done, Wi-Fi connection has been not done, then it just prints ... So it prints ... If it is connected, then it will print Nodemcu is connected. So till it keep for every 200 milliseconds, it checks the status of the Wi-Fi whether it is connected or not. If it is not connected, it just keeps on to ... Again, after 200 milliseconds, again it checks. So once the connection is established, it just prints Nodemcu is connected. So it prints the message. Where we will get this message? we will get this message on the serial monitor. Then the next statement is serial println Wi-Fi dot local IP. So this prints the local IP address obtained from the Wi-Fi network to the serial monitor. So it is used to print the Wi-Fi address, that is the IP address obtained from the Wi-Fi network. You can check it in the monitor after executing this program. So this is used to print the IP address obtained from the Wi-Fi network to the serial monitor. Next, we have DHT begin. So this is used to, this is used to initialize the communication with DHT11 sensor. For initializing communication with the DHT11 sensor, this is used. Next, we have Thingspeak dot begin client. So this initializes Thingspeak library with provided Wi-Fi client. So this Thingspeak dot begin client, it means it initializes the Thingspeak library with provided Wi-Fi client. Now after initialization, we enter into the while loop. And here we are declaring two variables, H for humidity and T for temperature. And the first line, H is equal to DHT read humidity bracket. This reads the humidity value from the DHT11 sensor and store it in the variable H. In the same way, in the second line, and this will read the temperature value from the DHT11 sensor and store it in the variable T. Okay. So after this, we have serial println temperature plus string T. So this will print the temperature value to the serial monitor. So whatever you want to print it on the serial monitor, so you should write using serial dot println, whereas the S should be capital letter and P should be small letter. Otherwise, you will get an error. And in the similar manner, the second one, to print the humidity, serial dot println humidity string H. So this prints the humidity value to the serial monitor. So after that, we have one more, Thingspeak dot write field, my channel number 1, T, my write API key. This will write the temperature data to the specified field 1. In field 1, it is going to write the field 1, what I gave, H I gave or T I gave something. So in field 1, it will write the temperature, and in field 2, it will write the humidity. If I have changed there, again I'll go and change there. So in field 1, it will write the temperature value, because in program I have taken in field 1 temperature and field 2 humidity. So it will write the humidity data to the specified field of the Thingspeak. Otherwise I'll change here only. So I'll field 1, I forgot, and I'll just check and tell you. Yes, in field 1, I have declared H and field 2 time. In program, again, I'll change there. I'll go to program and I'll change field 1 humidity. Field 1 humidity. So in field 1, I have typed T, I'll change here. So I'll make it as H. And in field 2, I have declared time. So I'll change here T. Only these things you can do it. So after that, we have a command delay 2000. So this will add 2 seconds of delay before the loop repeats and prevents excessive data uploads and allows the sensor time to stabilize between the readings. Okay. Now, how to upload the data and how to check the, how to make the connection with our DHT11 sensor and how to check the data in a Thingspeak, I'll show you. Aim of the experiment is interfacing DHT11 sensor with Nodemcu and Thingspeak to monitor temperature and humidity. For this experiment, we need Nodemcu, DHT11 sensor, breadboard, USB cable, some jumper wires and Arduino IDE software. The connection diagram of DHT sensor with Nodemcu. Here the VCC pin of DHT sensor is connected to VCC pin of Nodemcu, and the output pin of DHT11 sensor is connected to D4 pin of Nodemcu, and the minus pin of DHT11 sensor is connected to ground pin of Nodemcu. Here I am using DHT11 sensor and a Nodemcu. So I am using the pin D4. So you just count from the top: D0, D1, D2, D3, D4. D4 pin I am using, and below D4 we have a 3 volts pin that I am connecting it for DHT11 sensor, and below 3 volts I have a ground pin that also I am connecting it for DHT11 sensor. So here the connection I am doing like this. This is VCC pin of DHT11 sensor. I am connecting it to VCC pin of Nodemcu, and the middle one is signal pin. This I am connecting it to D4 pin of Nodemcu, and the last one is ground pin of DHT sensor. It is connected to ground pin of Nodemcu. Very simple connection. After doing this connection, you should go and upload the program. Before uploading the program, you click on tools and select the board. Which board you should select? Nodemcu 1.0 ESP12E model you should select, and after that you select to which port our Nodemcu is connected, that also you select. So after selecting a port and a board, then you click on upload button. So now I'll click on upload button. So once I press the upload button, it starts uploading the program, and it is almost done 100%. After uploading your program to the Nodemcu, you go here and there is a serial monitor symbol here. Here, click on this serial monitor. So it will open. So initially you should press the reset button of your Nodemcu. I'll press the reset button now. I'll close here once again. I'll press the reset button. Okay, you check in the serial monitor. It is printing ... till it gets connected to the Wi-Fi network. See, it is connected. So it will display the message as Nodemcu is connected, and it is displaying the IP address 192.168.222.197, and it is showing us the result, temperature 27.1 and humidity 72%. So we will check again the same thing on a Thingspeak. So I'll open the Thingspeak now. So this is my Thingspeak channel. In Thingspeak account, the data has been already updated. See the red line I got. So on Saturday, August 5 at 7:40, it is showing me humidity value 70%, and here also on the same day it is showing 28 temperature in degrees Celsius 28. So these two are updated in a Thingspeak. So if you check tomorrow also, so it will give the latest value of temperature and humidity, and it keeps on updating in your Thingspeak channel. So now we got the result in the Thingspeak channel also, and in the form of a graph, and we got result in serial monitor also. Once again I'll show you the serial monitor. See, I got 70 and 28. Same thing is displayed on Thingspeak channel. So this is all about interfacing of DHT11 sensor with Nodemcu. And one more thing I forgot to tell you, this USB cable you should connect to the laptop or a desktop before pressing upload button. This is your upload button. So please take care of whether you have connected micro USB cable to the Nodemcu and laptop or not. So thank you for watching this video.